All right, so here we're going to use our second derivative test again to find our extrema. Anytime you're finding extrema, the first step is our critical numbers. So we're going to differentiate here. The 3x squared plus the 15x is linear, so it goes to the coefficient. Plus 1 is a standalone constant, and then the 14x. All right, now you gotta love these questions where the x's are all sorts of mixed up. Remember, you want the highest power all the way down to your constant. So before you think about setting this equal to 0, you're going to rewrite this as 3x squared plus the x to the first term plus the constant, and then set that equal to 0. Now, what I like to do is just kind of have a minute by myself where I go over to the side, find a piece of paper, and go through the factoring of that, because that is going to be a rather involved factor step. And again, the reason why we're factoring is because we have a square, so we do have a quadratic equation, so we do need to factor. All right, so let's talk about the factoring of the 3x squared plus 14x plus 15 equal to 0. There is no GCF here, so that means we're just going to think about factors of 3 times 15, so 45, that add up to 14. Now, you might have to work here a bit to get to those factors, but eventually 9 and 5 are going to come to the forefront. So the 9 times the 5 would give you the 45, and then the 9 plus the 5 would give you the 14. Now, keep in mind, anytime it is not 1x squared, we need to split the middle and then group. So it's not as simple as just plopping down the numbers. So what we'll do is we'll split this 14x based on this combination. So that will be 9x plus 5x, and then the 3x squared comes down and the 15 comes down. Then we do our grouping. So GCF plus what's left over, GCF, what's left over. From the first group, I have a GCF there of 3x. So again, it's like I'm dividing this by 3x, dividing this by 3x, and that's going to give us just x plus 3. So then I need to get that x plus 3 from the second group. And if I look at the second group, I notice that they have a GCF of 5. So I can take out that 5. Now, both group 1, group 2 now have that GCF of x plus 3. And so that leaves us with the 3x and the plus 5. So that's my factorization. So I go back over here to where I was setting my derivative equal to 0, and I write down that factorization, x plus 3, 3x plus 5, equal to 0. And then I set my factors equal to 0. So that gives us x equals negative 3, subtract my 5 from both sides, and then divide by 3. Now, those two numbers, the negative 3 and the negative 5/3, those are where the first derivative is equal to 0, so those are critical numbers. Now, because they are critical numbers and because we're using the second derivative test, we are going to plug the critical numbers into the second derivative. So I take my second derivative, again, going back to right where I was setting it equal to 0, the 3x squared, so again, I'll write this here. So I have 3x squared plus 14x plus 15. That's my first derivative. Right where I was setting it equal to 0, I refer back to that. To take the second derivative of that, I would get 6x plus 14. And now I'm simply going to plug that critical number into the second derivative. So I plug in my negative 3, and one thing I want to say about this, sometimes people get really hung up on like the fact that it's negative 4. You guys think about like if you get a COVID test, like they just tell you like you're positive for COVID or you're negative for COVID, right? Like they don't actually tell you like what your viral load is in the COVID test. So I always like to think about any sort of test you have, whether it's the first derivative test or the second derivative test. Nobody cares if it's -4 or -10 or -12. All they care about is it positive or is it negative? Just like when you are getting a COVID test or any medical test, it's just the question of is it a positive test result or is it a negative test result? Now, the reason why I bring this up is because sometimes students will plug in or get the -4 and then they think that the -4 should be part of their answer. And that's not true. The negative just tells us it's concave down. So, what I would encourage you to do is not really write the -4, but just write the negative sign because it's a test. And with a test, you just care is it positive or negative. Now, what that negative tells us is because it's the second derivative, it tells us that we're concave down. And if we're concave down, we must have a max, relative or local max, at x equals -3. And the same thing is going to happen for the other critical number. We're going to plug it in to the second derivative. And that's going to give us -10 from the 6 divided by 3 would give us 2. So 2 times -5 gives us -10 plus 14. That gives us a positive. And all we care about is that it's positive. We don't care that it's 4. And then with that positive, that's going to tell us that it's concave up. And if it's concave up, then we have a relative min at that point. So at the -5/3. Now, of course, to make the homework people happy, what you need to do is you then need to find those coordinates. So to find those coordinates, you have your x, you have your y, you have your -3 and your -5/3. And you will simply plug in to the original function. So that's really important to keep in mind, plugging into the original function. So the x cubed plus 15x plus 1 plus 7x squared. And if you plug in the -3 into that original function, you'll get out -8. And if you plug in the -5/3, you'll get out the -248 over 27. And that's where using that math feature on your graphing calculator can be very helpful. So our final result is going to be that we have a relative or local max at the point -3, -8. And then we have a relative or local minimum at the point -5/3, -248 over 27.